There we go. Okay, so if we are officially on the road. So, hello, my name's Steve, and I'm a language addict. It's been about 3 months since I proposed rewriting our entire agent in another language, and I haven't proposed integrating Lua into any of our products for over a year. So that's pretty good. I feel like I'm making progress, but man, do I love computer programming languages. I love everything about them, from the high-level languages right down to the bits that make up an opcode. I think they're just a lot of fun. It's interesting to see how you can express different ideas or different algorithms or whatever better in one language than another language, or more clearly in one language than another language. And so I just really like languages. Oh, by the way, that link at the bottom, a lot of this session is actually code in a playground. And if you've got Xcode on your system and you want to go grab that playground, there's a long and a short URL to get to it. And I'll keep that URL up on a couple of slides still if you want to go grab it and look around. As I was explaining to the gentleman here up front a little bit earlier, I really like working in the Apple environment. And I have really liked Objective-C. A lot of people think Objective-C is kind of weird. I think it's a pretty great language. Other than, the whole decision of, okay, we've got C works pretty good, it's a nice simple language. We want to extend it to use objects, so we will kind of make it look like Smalltalk, kind of. We won't really make it act like Smalltalk, but we'll put lots of square braces in so it sort of looks like Smalltalk. And then we'll do some @sign things to extend the language, and it's kind of weird looking, but it's really powerful, and it really fits in well with Mac OS or OS 10 or whatever you want to call it. Because the two were basically grown together in the form of Next Step. So it's really nice. So when Apple came out and said, well, yeah, we recognize it's a little weird, but we want to create our own language to do system programming for the Mac, I was pretty excited. I saw Swift, and I became very enamored with Swift. One of the first things I did just playing around with Swift was to go out and dig through information that I was pulling out of System Profiler. For my day job, I write agents for Mac system administration for a company. And so I do a lot of trying to figure out the state of Macs. And as part of that, I'd call System Profiler, I'd dig through information and start playing around with doing that in Swift. And it was pretty fun. So I thought, well, this might be something other people are interested in. So that's where this little presentation came from. So given that, I'm kind of curious about who are you? I've given this presentation before, and the first time I gave it, I was pretty surprised at the makeup of the group. So how many people here have some programming background? They have programming experience. Okay, some.
Very ambiguous.
So yeah. So but you understand the idea of a variable, the idea of a loop, right? How many people here are like already Python programmers? You feel pretty comfy with Python or JavaScript?
Does anybody who's married understand a variable?
Maybe Bash. Okay, so I think we'll be okay. Kind of my expectation is this is sort of an advanced beginner to beginning intermediate class. It's very much about Mac OS, not at all about iOS, because there is no system profiler in iOS. You can't ask iOS system questions very well. It's just not designed to do that. So that's kind of my expectation, should be your expectation. Now, something to keep in mind, like I said, I love languages. I love programming languages. I can get very enthusiastic about them, and I can make a lot of really bad assumptions about what the people I'm talking to know about programming languages. So if at any point in this presentation I start spouting gibberish that doesn't make sense, go ahead, raise your hand and say, you're spouting gibberish, I have no idea what you're talking about. And I'll try to back it up, because my reason for being here is to try to help you guys learn something maybe you don't know, and I assume your reason for being here is because you want to learn something that you don't know. So hopefully we'll be successful with that, but it's kind of a two-way conversation. So are we all good with that idea? Okay, great. So things we'll cover. We're going to talk about running processes out of Swift. Swift makes it really easy, really clean. We're going to talk about how to get task results out into a usable form. So I've run System Profiler, or I've run LS, or I've run PS or something, and I've got this big clump of stuff and I want to make sense out of it. We'll talk about how to do that. And then, well, how to get it into a usable format. And then finally, how to make sense of the results, which hopefully will be the biggest part of the presentation. And I am right on time. This is great. This slide says I should be 70 minutes left, and I am 70 minutes left. I'm pretty excited about that because, like I said, I tend to ramble on a little bit. So let's just for clarity, just to make things nice and we know we're all kind of in the same place. I do want to talk really quickly about two data structures that are part of Swift, because if you don't understand what they are, we're not going anywhere. So let's pull up. Oh, a quick side note. So one of the things Swift gives you that if you just want to start playing around with programming, it's really nice, are these playgrounds. I don't know if any of you are familiar with the idea of a REPL, or a read, execute, print loop, where you can just go and start typing code and things happen and you can play with the programming language. Apple in Xcode has provided one of those called a playground, and you go in, new file, playground, and you can just start typing code and playing with it. So that's what I'm going to use for most of this presentation, is a playground, so that we can see things immediately and play with the code. And that's what you'll get if you go to my GitHub site and download that project. You get a playground that you can bring up and fool around with. So there's two data structures that are important to this talk. The first one is an array. Hopefully people are fairly, you understand what an array is. It's just a collection of something. So in Swift, there's a couple of ways to say I want an array. Both of these two lines are exactly equivalent. I can say I want an array of int, and I'll have a literal array, 1, 2, 3. Or I can use kind of their little shorthand that says, because they love the square brackets still, can't give that up, right? I have an array of int, and again, 1, 2, 3. So that's how we create arrays. We're going to use a lot of arrays, obviously, because when you pull information out of the system, you're going to get a bunch of stuff in an array. The other thing is a dictionary. So a dictionary is, again, it's just a collection that associates values of one type with values of another type. So in this case, I've got a dictionary that takes strings as keys and integers as values, and then I have a literal array where 1 maps to the number 1, 2 maps to number 2, 3 maps to number 3. Again, there's this kind of long way of doing it that's sort of C++-C looking, right, with the angle brackets, and it looks kind of like a template. But then there's the sort of I don't know if you'd call it nicer. I like this because it's short. It's a lot less typing, and that's the point of any programming language, right, is to cut down the amount of typing you have to do. But again, I just say this is a string key, an integer value, and then the same thing gives me the same 1, 2, 3 gives me the same end data structure. Dictionaries are super important. How many of you are familiar with p-lists? Okay, so do these two data structures seem familiar to you if you're familiar with p-lists? Because p-lists are generally arrays of dictionaries or dictionaries of arrays of values, right? And since we're going to be messing around with p-lists a lot, that's where this is coming from. Okay, so we good there? All right. So let's talk about firing up an application, because that's what we want to do. That's really the big kind of heart of this presentation is I've got an application or a tool I want to run, and I want to suck data out of it. So running a process in Swift is super easy. So here I have a let statement. So that first one, let ls, let's see, they said it was C? Haha, can you see my, oh, nice, okay. So let ls proc equal process. That's saying I want to create a new variable called ls proc. I want to create a new process type, or a new process object, and I want to stick it in ls proc. Pretty straightforward. You notice I didn't have to provide a type or anything. So if you're used to scripting, this is probably pretty comfortable. The compiler is going to keep track of this stuff, that I've created a process got stuck in here, so this variable is now of type process. Swift is a strongly typed language. Once I've done this, I can't stick an integer or a string or anything else in there. It's got to be a process. Under the hood, it is typed. The type has been assigned. And the same goes for the next line where we say, std out is pipe. So I'm going to grab a pipe. So if you're a bash programmer, what's a pipe?
The output of one result, or the result of one command into the input of another.
Right, it's the result of one command that output to the input of another. It's exactly what it is in Swift as well. You create a pipe, and you can use that to string together code, to string together applications. So what I'm going to do is I'm going to connect, well, let's keep going on with the slide. So the first thing I want to do is I want to set up to launch. In this case, I'm just going to launch an ls-l. So on my ls proc, my process, I'm going to set my launch path to bin ls. I'm going to set my arguments to -l. Pretty straightforward, right? Then I'm going to grab my standard my standard output. So I'm going to kind of screw that pipe into this procedure standard output. And then I'm going to launch and wait until it's done. You don't have to wait until it's done. You could then, if you wanted to, go into a loop and be reading stuff from standard out, whatever you want to do. But in this case, everything we're going to do today, all the data we're going to get out of these program calls is small enough that we can just read it all in once the program is finished running. So I'm going to launch and wait until it's done. And then here, I'm going to take that standard out pipe that we had up here. I'm going to ask for its file handle, which again might be familiar to some of you, might not, but it's just an integer. It's an operating system object that says this number is associated with this output. And I'm going to hook that into a file that I can read, and then I'm going to read all the results of my output till the end of the file, and then print it. That's really all there is to firing up a program in Swift. It's nice, it's easy. I mean, compared to something like Python or Bash, maybe a little more complicated, but not much, right? Any questions about this code? All right. So let's talk a minute about System Profiler. How many of you already work with System Profiler frequently? Okay. How many of you have never touched System Profiler at all? You just don't know what it does. Okay, nobody. That's good. System Profiler is pretty useful if you're trying to figure out the state of your Mac. So in this case, this is an example of if I ran System Profiler with the SP hardware data type, I would get information about my Mac, and I would find out. In this case, I was running it on Parallels, obviously, and I can find out the hardware ID. I can find out all kinds of things about the Mac. So but this is what the output generally looks like. You have maybe some empty lines, but generally you have a name, a colon, and a value. So what kind of thing is that probably going to call for? I mean, have any of you already done this kind of work in whatever language you're used to, where you're just going to walk through lines and split them apart based on some separator? Right? There shouldn't be any mystery here. That's exactly what we're going to do. We're going to walk through the lines here. We're going to look at a separator. In this case, we'll probably choose the colon and separate them out. So here's some code to do that. So again, it's very similar to what we did before, right? I skipped the part, create the process, create the pipe. So I set up the process. I'm going to run System Profiler with the SP hardware data type, wire up the standard out, launch and wait, and then I'm going to read in the result, just like I did before, but this time I'm going to do this last little line here that says we're going to take that SP text output and we're going to break it into components separated by new line. So what that does is it breaks my output into what? What's that? A list. Well, in this case, it's going to be an array of lines. So every line from my output is now going to be in its own element in an array of strings. Now, see that little question mark there? This is one of the things I really like about Swift. What that question mark means is I probably will get an array of strings that represent those lines. This says that my output, my lines, is actually going to be what's called an optional, because something could have gone wrong, right? When I was reading data in, anytime you're doing I/O, something can go wrong. And so what this does is it kind of codifies the idea that I either got something back or I got nothing back. And that's what this optional lines thing is. It's either going to be an array of text or it's going to be a nil. And that's the only options. So we can then, and ignore that exclamation point because that's really bad, but we're not going to talk about that yet. We may not talk about it at all. But the lines is just a way to say, I believe with all my heart that I did not get a nil back. I really believe I have an array of strings. So I'm just going to go ahead and assume that's true. If it's not true, the program at this point crashes spectacularly. It throws unfortunately, it throws an Objective-C exception, where in Swift there's really no way to catch an Objective-C exception, and everything just explodes. So we're going to make that assumption. We're going to go with that belief, right? So this last section is then me picking apart the information. So I'm just going to say for each line in lines, I'm going to do that components thing again. I'm going to break it into pieces, but this time I'm going to break it into pieces based on the colon. So now line by line I'm going through, I'm breaking it into two parts. I am going to then look and try to find out if the first half of that pair that I've created, right, the key value and the data, contains the word hardware UUID, and if so, I'm going to print that part. So what this is doing is it's firing off System Profiler with the SP hardware data type, and looking for the hardware UUID of the machine I'm on and printing it out. That's what this code's doing. Something you may have done yourself in some other language. So, so that's really great if I'm running, if I'm just looking for a UUID, because I know what that piece of data looks like, right? It's always going to be a single list with pretty unique keys down the side, and I'm good. And that's nice, but what if I'm looking for information on network interfaces? So if I look, say I'm looking for just an IP address in the System Profiler output for, man, that is loud. In the System Profiler output for network information, if we do that, I get something that looks like this. I don't have unique keys anymore. So suppose I wanted to go through and find, the IPv6, or the IP, let's say IPv4, looks like it's there. No, the IPv6 address of my Wi-Fi. Well, I've got other IPv6 addresses in this list, so now I have to keep track, right? I got to go, okay, what section am I in? Go down until I see something else that looks like a new section, and it gets really ugly. So what Apple has done is they've given us the option to do the XML command line option for System Profiler, and now we get back a plist. And that's nice, right? Because plists are all nice and structured, and I can dig through data much easier because I can look for keys and values. I can look for the key that says this is my, an Ethernet, and then I can dig down in that sub-dictionary to say, okay, and this is the IP address or the IPv6 address for that Ethernet connector. It's just a little more straightforward. Now, one of the weird things about this, though, is it doesn't just give us that information. You can see up here at the top, it gives us back the command we used with some extras for some reason, like no spawn. I didn't type that in, it says I did. It tells me that I set a default level, which I didn't. It gives a bunch of other stuff, and we get down here to this items, _items, and this is the actual data we want. So this is the stuff we want to look at, but then we get to the end, and suddenly we are looking at this stuff, which is like column information, ordering information, and names of things, which is, if you think about it, if you go on your Mac and you go up here and you ask about this Mac and you say, give me a system report, this is just information that comes out of System Profiler with column names and such, and that's what you're getting, right? What System Profiler is spitting out when you do the XML thing is all the stuff you would need to do to build this interface on the fly. So, what's the point of all that? The XML argument is very useful because it gives us this plist that we want, something we can read, something that's structured and we can dig through using keys and values and know something about. However, it also gives us a bunch of other stuff we're just not interested in. So let's go look at some things in the playground here. So I have a function in my examples that is called get items from System Profiler. Right here. Is that big enough? Oh, that's pretty good. Everybody see that well? Okay, so get items from System Profiler takes a key, which is, SP hardware data type, SP network data type, SP whatever data type, and it calls System Profiler with that data type, gets the information back, and then it goes ahead and for me starts digging down to that items subpiece. And it throws everything away except for the stuff under items. So this is just a little function that gets rid of all that cruft that System Profiler is throwing back at me. And now I've just got the stuff I want. So we're going to use this function quite a bit. Again, it's almost the exact same thing that I did in the other two examples, only this guy has this extra bit at the bottom that is digging down through these through the dictionaries. So here I can say, I'm making an assertion here that the thing I got back is actually a dictionary, or excuse me, is an array of any object. And if it's not, I'm going to give up. And then I'm going to say, okay, and if that contains a dictionary of strings tied to any object, and any object is just sort of an n-type value, right? I'll take anything there. You can give me, well, you can't give me an int, because that's not an object. There's actually an any type that will take that too. But any kind of object, anything that's a more complicated thing than an atomic data type, I can stick in there. So I say I've got a string of anything, or excuse me, a dictionary that's a map of string to anything. If that's what I've got, then that's what I can return, and I'm happy. Okay, does this all make sense? Seem like something that might be useful to use, right? I've got it nice and put away where I can get at it. So let's look at, so this is that getUUID function that I showed before. Let's actually watch it run. So there it went, right? I uncommented the code. The playground recognized that I'd made a change. And it's kind of annoying with the playgrounds, because as you're typing, it's just every time you hit a key, every couple of keys, it tries to run your code. And so most of the time when you're working in it, you've got this great, big, ugly error down at the bottom saying, I don't know what you're trying to do, because I haven't finished talking yet, right? But it doesn't know. The playground has no idea that that's the case. So you just keep typing, and at some point, your code finishes, and it's happy, and it runs, and in this case, there's the output, right? There's my UUID for this machine. One thing to take note, though, if you're giving a presentation to a group of people and you're using this a lot, sometimes Playgrounds just finally gets tired of you typing stuff it doesn't understand and stops trying to run your code, and it's kind of a hassle. Well, I've had Playgrounds just completely give up on me while I'm doing this talk before. If it happens, it happens. We'll just deal with it. Okay, so any questions so far? All right. So that's how we get the stuff. And that's how we get it into a format that we care about. So now we're going to talk about making sense of the results. And really, this is the most important part, right? Getting the stuff, you can use a library off the shelf of some sort, or use some guy's code off of GitHub to get the stuff you want to look at. But digging through it and finding the information you want to find, that's the harder part. So that's the part that we want to spend time on. So to do that, we need to understand one other or a couple of other kind of weird concepts. We're going to talk about a little bit about lambdas, or if you've ever done any Objective-C coding, it's the same as a block or an anonymous function or whatever. Depends on what language you're used to. We're just going to talk about them a little bit. They're really cool. They're pretty straightforward. We're going to talk about kind of the basics of iteration, but in this group, I think everybody's kind of got the grasp of what a loop is, right? And then we'll talk about using functional concepts to dig through this information, and that's kind of fun. Now, again, this is where things could go off the rails, because, man, do I love programming languages and functional concepts. Functional programming, that's the new hot thing, right? So it's like handing me, a couple little pieces of crack, saying, here, go ahead and tell people how much you love it. But it'll be okay, honest. So lambda functions. So here's a function in Swift. This is just a basic function with all of the pieces you might need to say this is a function in Swift. So I say it's a function. I give it the function name, add 1. I say as a parameter, it takes one parameter that I'm going to call I, that's the name of the variable, and it's of type int, and it returns an int. And all it does is add 1 to A. So that's how you declare a function in Swift. Pretty straightforward. Again, looks a lot like you might see in some scripting languages, but Swift isn't a scripting language. It compiles it all the way down to the bits, and it is strongly typed. So sometimes little hunks of code are fun to pass around as though they were values. And this is one of the things Smalltalk did a lot, right? And this is something that a lot of the functional languages really like. So maybe I don't want to create a function. Maybe I want to create a variable that has code that I can pass around and do things with. So I can do that in Swift. So here is the big version of that. So these two, again, are equivalent. I've created a variable, call add1, that takes a hunk of code that takes a parameter, a, that's of type int, returns an int, and then, the syntax of this is a little odd, but if you look, basically, this open curly brace is replaced by this, because we've already got an open curly brace over here. And then here's the body of the function, and we're done. Okay? So these two are sort of pretty much equivalent. There's some really weird nuances. But really what's happened here is I've created a variable whose type is a function that takes an integer as a parameter and returns an integer as a value. And that's the type of the function, or of the variable. Does that make sense? Is that a little odd? Anybody just like going, oh, no, I can't deal with this. Okay. Now, Swift is nice to us. That's a lot of typing, right, to just add one. Why do I want to type all that stuff just to add one? So there's ways to kind of crunch that down. Swift is figuring out types. Remember we did the let a equal or whatever, and it just kind of figured out the types and assigned them properly. So here, if I do this same line of code, but I do it like this, Swift is going to say, well, right here we've got a 1, and I can only really add 1 to an integer, and I'm returning that, so I'm going to just assume this guy wants to return an integer. And since I can really only add 1 to an integer, this must be an integer too. So it's going to just kind of figure that out, right? It's elementary. It's going to deduce that those are the types we have involved. It's going to take care of it for us. Again, it's not type-free. It's strongly typed, but the compiler is just going to figure it all out for us. But it's still a lot of typing, though, isn't it? I mean, I got to do the in return, and I got to type an A. Well, the A is actually less than what we're going to do in a second. But I've got another option. This looks more like a scripting language at this point, right? $0 means what? Yeah, it's the 0th argument, right? The first argument list. So what I've said here is just take the first thing I get and add 1 to it. All 3 of these guys here will generate the exact same code. Okay? And they're all going to generate a variable that contains a function or a hunk of code that takes an int and returns an int. We good so far? Okay, so here's kind of a fun example that we're going to use in the rest of this presentation. Suppose I want to know how long it takes to run a hunk of code. I want to do kind of a little off-the-wall profiler. So what I want to do is I want to have a label that I can print out that tells me what it is I'm timing, and then I want my hunk of code. So what I've done is I've created a variable that takes a hunk of code that has a void or no parameter and returns nothing. And then I'm going to grab myself a date, which is, for some of us a little tougher than for others. And then I'm going to go ahead and run code, the thing I passed in. I'm going to call it right there. And then I'm going to grab myself another date. Well, I'm going to actually grab the time interval since the first date and print it out. And it will print out, some teeny amount of seconds. So does everybody understand what's happening here? I'm actually going to pass in a chunk of code, and this guy's going to do the running of it. So when I write the code, it's not going to be executed where I wrote it. It's going to be executed when this function runs and calls it. Okay. So I think we have the foundation for what we're going to do next, which is what I like to call my journey through iteration. I know that sounds just absolutely fascinating, my journey through iteration. But it kind of shows you some of the cool features that Swift has and the flexibility of the language, which I'm just really impressed with. So I'm going to go ahead and I'm going to just uncomment this whole mess here, hopefully. All right. So what I've done is I'm calling get items from system profiler. That's the function I wrote that's over in my utilities, my little utilities file over here. And this is another kind of cool thing about the playgrounds. I can build myself little utility stuff and stuff it off to the side so I don't get this big cluttered playground. The stuff so I developed that function, using the playground. Then I packaged it up and shoved it off to the side so I didn't have to look at it every time it ran. You can actually, even if you're developing like frameworks, you can do a framework in a playground and call functions directly down in your framework you're developing to exercise them interactively. It's just fun. Okay, so here's the scenario. I want a list of all the bundle IDs for all the applications that I have installed on my Mac. Believe it or not, that's a real scenario that came up in my everyday work, right? I needed a big list of bundle IDs for everything, for all of the applications that had been installed with packages, with PKG files on my Mac. Well, actually, for all the applications on my Mac. So there is a system profiler call you can do, SP application data type, that will give you the big list of all your applications and a bunch of information about them, but it will not give you the bundle ID. But that's what I wanted. So what I decided to do is I'd go ahead, I'd call that, get the big list, and then do some massaging of that data to get the bundle ID and stuff all the bundle IDs into a big array of bundle IDs. So here's what I did. So this is sort of a first, back. This is sort of the first shot at it. So this is using a traditional for loop. It's running, and there we go. So here's the output of that time me function, right? Here's time me. I passed in a label, traditional for loop, and then I did a sneaky thing that Swift lets you do. Because I'm doing a code block as the very last parameter, it lets you go ahead and kind of tie off your function call and then tail it with the code you want as the Lambda. So all of this stuff here, all of this stuff here is actually, here, is actually a parameter being passed into the function. So this is just sort of a syntactic sugar thing. I could replace this paren with a comma and stick the paren down here, and it would work, because that's all code that's being passed in. Okay, so what am I doing here? Well, this is a traditional for loop. So something you might see in C, for some value from 0 to some count, do stuff, right? This is the way you would do that in Swift. I'm saying for a number in a range from 0 to the number of things I got back. Go ahead and do, and then it has, so what I'm doing is I'm saying, okay, if I can get a path out of the dictionary that's in this array element, because I have an array of values that represent application information. One of the data points in that array of dictionaries is a path. So if I can get the path for the thing, then I'm going to go ahead and I'm going to get the bundle for that path, so the bundle for the application, and then I'm going to pull out its bundle identifier. And that's what happens. So if I come down here and I say print, what did I call it? 4A. See, this is the big crash, right? Because I had typed in some things. And there it is. So now I have an array of optional strings, because something could have gone wrong at any moment, of all of the bundle IDs of all the applications on the system. Any questions about that? Is anybody just going, I have no idea what you're talking about? I don't know where you are or why you're doing what you're doing? This is all, I mean, from where you're at. Seriously, if you're stumped or you're going, I don't know why I'm here, let me know. I'll try to fix that. Okay. So one of the interesting bits in there, though, is the time. So let's get rid of that. I should get rid of that call too. So when we were done, it took 129 milliseconds, right? So that's a for loop. Now, I don't need to do that. This range thing is kind of stupid, right? Because if you're a scripting person, you're going, why would you do that? That's stupid. You're building this array of these indexes and walking the indexes when I have a collection of stuff. Why not just walk the collection of stuff? Which is a for in loop in Swift, which is really the only kind of for loop we have. Again, it's the syntactic sugar thing. So I can do the same thing, but I can do it with a loop that says for app info in the dictionary I got back from my call, do stuff. Now the problem here is I'm going to get an output that is more or less the same size as the input, but maybe not. Well, actually, it is going to be the same size. Oh, you're not running, are you? Do it. Okay, you can see this guy. You can see over here. It's like you can watch it running. It's really slow all of a sudden. So what's happening here is because I'm trying to stick right to the idea, the soul of a for-a loop, a for-in loop, where I don't have to worry about sizes of things. I'm actually going ahead and I'm just building a new array by appending to an empty array. So if you look, this for-a thing here is just an empty array of optional strings. That's what the question mark means. And as I get them, I'm just appending as we go along. What does appending do every time we append something to an array? It allocates memory. Memory allocation is death in programming languages, right? Memory allocation will kill you every time. And that's the difference. This guy, we went ahead and we found the size of the data we got back, and we pre-allocated ourselves an array. We basically created an array of nils and padded it out, and then we just stuck them straight in. And you can see the difference, right? I went from 129 milliseconds to 7 seconds. So the lesson here is don't do this. Avoid appends at all costs because they will kill your performance. Try to stick to pre-allocated memory or what we're going to do here in a second. So one last, just because I want to pound this point home, this is kind of the same thing. So the for in, we're going to pre-allocate our array in this case and run. Most of the time that's going on here, by the way, is the call to system profiler. Well, and then this guy. I'm gonna shut him down once we see this work its way through. Okay, so you can see just by pre-allocating, this is basically the same code except for I've pre-allocated the array, and I dropped down to 49 milliseconds. So that's pretty good. Let's just comment this thing out because it's going to slow the whole thing down. That's a bad example. I found sometimes bad examples are useful, though, to convince people that it's a bad idea. Now, that's the traditional way of doing iteration over loops. But there is a new fashion, right? A new style, and that's functional programming. It's really cool. Anybody here familiar with the idea of functional programming? And basically the idea is we are going to, instead of telling you how to do things, instead of saying, I want you to look at each element in this array and I want you to do something for it, we're going to say, you know what, just kind of do this thing to this thing. And we're just going to sort of declare what we want to happen. And we're going to let the operating system sort out what happens. And there are a couple of basic operations that are involved in this. There's the idea of a map, which I'll go into detail in a minute. The idea of a filter, which I'll go into more detail in a couple of minutes. And then there's the idea of a reduce, which is really complicated. So I'm going to save it for last, so we'll run out of time and I won't actually probably talk about it. But hopefully we'll get there, okay? So map. Let's just talk about map for just a second. Map's kind of a cool idea. What it does is this. It says, I have an array of one type of values. I'm going to take each value in that array, I'm going to push them through some function, and create a new array that is potentially some other type that is the result of that function. Pretty straightforward, right? So I'm just going to apply a function to each value in an array, and the result is a new array that may or may not be of the same type as the old array. Any questions about that? So instead of specifying for each element I want to do this, I just say, take this array, apply this to it, give me a new array. So I just happen to have an example of that, again, doing the exact same thing as we've been doing right here. So this is doing that same work, only this time, as you can see right here, I'm just saying map A is, and then I'm mapping, let's see, I'm calling map on D, which is my array that my array I got out of here. So I got the array of stuff out of get items from system profiler. So I'm mapping the values in D. Oh, that's the wrong one. Wait, get rid of that. That's a spoiler. Delete. There. Okay. So I'm calling map, and then this stuff in here, whoops. The stuff in here is a lambda. It's a hunk of code. So I didn't want to go out and I could have written another function and passed in the function, but that's a lot of work to write another function, right? So I just am giving it the data, the code that I want applied to each element in D. In this case, it's the exact same stuff as I was doing here, right? I'm getting the value for path. If the value exists, I'm getting the bundle for it and returning the bundle identifier. So if we look, with map in this case, it's similar to doing an enumerated loop. And if we run it a couple of times, we'll see that's kind of the way it works. But one thing though, I'd never had to worry about how memory is being allocated, right? In the other functions, either I was appending to the array, which slowed it down, or I had to say, okay, I know my array is a particular size. I will pre-allocate the values or the room for it, fill them with nils, and I will go through and I'll do all this other stuff. With the map, I don't have to worry about any of that. Don't have to worry about memory allocation, don't have to worry about types. Everything just happens for me. So any questions about that? Can you see the use? Right? It's a transform. I have data over here. I want it to be something else. I give it the rules for the transform. I get back a new array. Okay. No questions, concerns? All right, so this is fun. Now, one of the interesting things about map is it gives a lot of information to the compiler. If I write myself a for loop, the compiler really doesn't know a lot about what's going on up here, right? He says, I know I want to, for each thing in this array, which I want to do some work. I don't know if there's side effects. I don't know if changes down in here are going to affect things up here. There's a lot of things I just don't know about what's going on in this loop. But if I use map, the compiler knows I am doing exactly what I said I was going to do. I'm going to transform the stuff in the one array to something in another array. So that gives the compiler information it can use to optimize your code, which is really nice. The compiler can make all kinds of assumptions and do all kinds of cool optimizations. Now, one of the things most other languages that do map will do as far as an optimization goes is it knows that if I'm doing a map, I don't care what order it happens in, because each call is a direct one-to-one mapping. So I don't care what order it happens in. None of them are going to affect the other ones, which opens us up for what? Any ideas? Multi-threading, exactly. It opens us up for parallelization. So the compiler, for a lot of languages that support map, also just automatically do a parallel version. And if you have enough values in your array, it'll just automatically start spinning that out into multiple threads. Swift doesn't do that yet. I'm not sure why, because it's pretty easy. In fact, it's so easy. I stole somebody else's code and did it myself, right? So this is actually code I got from here. It's in an older version of Swift, but what it does is it implements a parallel version of map. One of the kind of cool things you can do with Swift is you can add functions to existing data structures. So if you have something you're doing to arrays a lot, you can just, after the fact, add it to arrays. And that's what's happening here. I've created an extension on array that I'm going to call pmap that creates a parallel version of map. We're not going to go into the details because they're ugly and complicated, right? Well, they're not that ugly, but more ugly than we probably want to look at here. But if I go in and I change this guy, well, let's let him finish out. So a map gave us 39 milliseconds. If I say pmap, that's all I had to do. Now that stolen code that I have ran, and I'm down to 17 milliseconds because I parallelized it out. I think that's a really nice feature of Swift, to be able to do those extensions on any kind of collection. And I could apply that to anything that I can do a map to. I could do the same thing to a dictionary or whatever I like. Yeah.
Can I show how many threads it
So I don't have that set up. When I was working on it, I did. I probably should. But it adjusts. So we actually asked the operating system, how many is my best number? Because you can ask Mac OS that. When you're writing threaded software, you can say, what is probably the right amount? How many processors do I have and such? And it will make those adjustments for you. So yeah, but yeah, I don't have a setup to demo that. I probably should. But it's nice. It's fun. So that's map. The idea behind map, again, just to summarize, is to transform data from one thing to another. So, any other questions? All right. So let's talk about filter. Filter is another kind of functional operation where I have an array of something, and I want another array of the same thing with less stuff in it, right? I want to filter it out. So maybe I only want even numbers, or I want, strings that start with F, whatever. So I can do that. So that's what filter does. It's pretty straightforward. So the example I have, nope, let's see. I'm in the wrong one. For filter, what I want to do is I just want to find network interfaces that have IP version 4 interface, or excuse me, where's my filter? Yeah, that have IP version 4 addresses attached to them. So if you look, it's your usual Mac, right? So I've got all kinds of crazy stuff going on. I've got Wi-Fi and iBridges, and I've got my USB-C adapter, and all these things. If I ask about network information, all that stuff comes out in my network information. So I wanted to write just a little program that would just tell me what interfaces actually have active IPv4 addresses on them. And so that's what I did. That's what this guy does. So I call get items from system profiler on SP network data type. I get my array of dictionaries, and then I say I'm going to create a new array called inames, and I'm going to create that by filtering. Okay, so this is a little bit weird. We're going to talk about this. We'll talk about it now. So I've got my array. I call it NI for network interfaces, right? Now again, NI, maybe it succeeded, maybe it didn't. I might have a nil. So I want to make sure I'm doing the right thing. I want to make sure that I'm not going to cause a crash. This is another one of the ways Swift gives us to deal with that. I can say, I want you either to use NI, or if NI is a nil, just give me an empty array and do the process on that instead. So this won't crash. I might be doing it on nothing, but it won't crash. So that's nice. So I'm saying, so on this stuff, either what came out of NI or an empty array, apply a filter where I take a lambda that takes an A, returns a bool, and it just checks to see if the IP address field in that dictionary is not equal to nil. And then once I do that, I print out my interfaces. So I say for whatever, for each device that came back in inames in this new array, go ahead and print it out. Now in the case of this guy, let's see. See, I may have just run into Playgrounds deciding to give up the ghost on me. So I might have to shut down Xcode really quick and start it back up. I was warned. When I started this presentation in another context, they said, "You're using Playgrounds in a presentation? You're an idiot." And I said, "Well, yeah. Tell me something I don't know."
Well, somebody earlier today did that too, so we're in good company.
Yeah. Let's see, who is doing a presentation today on Playgrounds? All right, so hopefully this guy is not going to crash this time.
I think it was named Rich Apple.
Yeah. Something is up. I hope I didn't change anything I shouldn't have. I'm going to have to get all the way out of Xcode. I thought maybe just closing the project would do it.
What's the oldest OS that runs that you can run Swift or produce code
That's a good question. Yeah. All right, let's see if we can get this guy to, there we go. Okay, there we go. So there's the result of my code. The only network interface that I have that actually has an IP4 address attached to it is my EN0, right? But that's kind of nice. With just this few lines of code, you know, I dug through all of this, or the equivalent of it, and was able to find that fairly quickly. So any questions about filter? Filter is pretty straightforward, and again, in a common scripting terms, pretty useful. And again, I could have done this with a loop, right, with just a regular for loop or whatever. But by using filter, I'm telling the operating system, you know what? Again, I don't care about the order. I don't care there's no side effects. Just go for it. And I could do a parallel version of this function if I had the time, if I needed to for some reason. So giving the compiler extra information is always good. Give it as much information as you can. Okay, so let's talk about reduce. Reduce is a little bit odd, and it can be, maybe it's just me, but it can sometimes be a little confusing. The idea of reduce is I'm going to reduce data down in some way. So I start out with an array over there. I feed each element of that array into a function. And then I take the result of that feeding, of that iteration of that call, and I loop it back around and I shove it back in again, and I take the next element and I apply and I combine the result of the previous call to the result of the next call. Okay? So the simple, probably the dead simplest example of that is going to look something like this. Let's see, I might already have one in here. So the probably the most dead simple of that would be something like, I already built myself up here an array AT that's an integer of all the values between 0, 100, not inclusive, right? So 0 to 99, basically. So here, if I wanted to, I could say at.reduce. Now I have to give it some sort of initial value, because the first time we call the function that I'm going to pass into this has to take 2 parameters. And the first time I call it, I've got nothing, right? I've never called the function before. So I have to give it an initial value. So we'll just give it an initial value of 0. And now we're going to give it a lambda. And I'm going to be really lazy about this. I'm just going to say $0, return, actually I don't have to do that either, because this is Swift. $0 plus $1. Come on, do it. Okay, so there we go. And what I got was, wow. Okay, this is kind of interesting because it shows me all the intermediate values. So let's just go ahead and say print that. There. So if I sum all the values between 0 and 99, I get 4,950. And that's a reduce. I am applying a function to everything in an array, and I'm doing something to aggregate the values. If you're from a SQL background, this is an aggregation function. So we've got transforms, we've got reductions or filters, and we have filters and we have aggregations. And that's what reduce does. Reduce can be tricky. And this is sort of, okay, this is actually kind of annoying. This is my bad reduce example. And when I wrote the presentation, it was a really, really bad reduce example. I should go and I should just comment a bunch of stuff out. And I'll explain why in just a second. I'm just going to comment some things out to reduce some clutter. well, reduce clutter. That was nice, huh? And we don't want that guy really going off. We'll cut down on so that you can see what's going on. Okay. So what I have here is a function that is going to use sp-install history data type, which is a way to find out all the times you've installed software using a PKG file. Okay, so every time you go to the App Store and upgrade something, every time you install something, the operating system keeps note of that. And if I go here, there's actually somewhere in here, there's an install history, installations. And I can see all the times that, so you can see here, for some reason the Chinese word list has been updated twice. AnyConnect secure mobility client's been updated twice. And what I needed, and this again, this is a real world example, this is something I was doing for an agent, I wanted to know the earliest install of every application that I knew about. And so I wrote this code. And it's a reduce. So here I went ahead, and so I'm calling sp-install history data type, getting back some installs, and then I'm creating an empty array of dates. And what this is going to do is it's going to give me back, the idea is I give it this big array of stuff, and I get back a smaller array, or maybe it's a dictionary. I can't remember. It is a dictionary, sorry, that has the name of the application and the earliest install date. Okay? But it's a reduce. And one of the rules of reduce is when I do that return, the return is always by value, never by reference. So as I'm building this array, every time I return my value back, I have to completely rebuild the array from scratch. So when I put this demo together, this function took like a half a minute to run. It took about 30 seconds to run. Now, I don't know if you noticed, it ain't taking 30 seconds to run anymore. Well, okay, it's taking a little longer. Problem is this. When I wrote this, I had a Mac that I had been working on for 2 years, and I had a huge install history. This is a brand new Mac. Pretty excited about a brand new Mac, right? Except it screws up my demo, so oh well. But anyway, the point of that rambling is that as I do this, every time I have to create this new result variable, and it has to be standalone. It can't be just taking something from the parameter list, adding to it, and then piping it back through. It has to be an atomic data type. So in this case, it doesn't look like a bad example, but if I'd been using this machine for a year and I had a bunch of install history, it would be horrible. You're just gonna have to trust me on this. So I was trying to figure out a better reduce example. And so what I thought was, okay, so reduce. Suppose I have a big list of processes and I want to find out which process is taking up the most of my processor. That's a reduce, right? I'm only going to be handing back one value every time I go through, whoever the biggest hog is at the moment. So I wrote this. Now this is an interesting little bit of, this is the command line for the thing I'm going to do. So I'm going to call ps-a, and then I'm going to just get the CPU amount and the name of the application. And that's what I get back. Again, this computer is just nice and fast, and everything looks like it's not taking up a whole lot of stuff. But there's all my processes, and the first column is how much time they're taking. The second column is the name of the process. Okay? Kind of fun? All right. So back to here. What I do, now I had to create a little bit different function for this because I'm not going to get a plist out of ps, right? So I have a function called launch and get text, which just launches the function and gives me back all the text it came from. It's exactly like the other stuff we've seen. If you want to look at it, we can look at it, but it's not that interesting. Okay, so I'm calling ps-ax with those same parameters, and then I do the thing, right? I say, okay, now I'm going to get each individual line. I'm going to knock off the first one, because if we go back to our output, the first one is this. It's this % CPU comm. I don't care. And if the last line is empty, I'm going to knock it off as well. So now I am going to take this PS lines, the stuff I got back, and I'm going to run it through reduce. Initially, it's going to get an empty string. It's actually, okay, in this case, what I want is a pair. I want a pair of things. I want a string, the name of the application, and a floating point value that is the amount of time it's taken for my processor. So we're going to use some extra parentheses here. And this, symbol overloading can just drive you crazy. Because this looks really odd, right? I've got open paren, some stuff, close paren, close paren. This open paren, the outside open paren and close paren, so those guys, those are for the function. The inside says what I'm looking at is a tuple. It's an arbitrary collection of values. So this open paren here says I have an arbitrary collection of values that includes a string and a floating point number. And this together is my initial input into the reduce. Does that make sense? And what I want is that same thing back out, only with my hog function, or my hog process. So here I have two things, current hog and a potential hog, and what I'm going to get back is a string and a double in, and then I have my lambda. So this function is a little bit more complicated than it probably technically needs to be because of the way Apple has chosen to handle strings in Swift. Good news is Swift 4 has put a lot of thought into what they did, right? They went to the corner, think about what you did to strings. They thought about it. And what happened was they came back and said, okay, yeah, maybe it's a little overcomplicated. And they've cleaned up some of their string stuff. But their heart was in the right place. Apple's really serious about multi-byte characters. And multi-byte characters cause funny problems when you think about strings. Are you thinking in characters? Are you thinking in bytes? If I ask for the size of a string, what do you want? Do you want bytes? Do you want characters? And so they came up with this whole kind of weird way of thinking of strings. And so we'll look at this in a little bit more detail here. So I am going to, rather than do a components thing, I'm going to do a split. Because if we look back at this, these columns are not necessarily delineated by a particular separator, because we have spaces over here, we might have some spaces elsewhere. They're really delineated by location. So I'm doing a split that's based on well, it's based on spaces, but I'm trying to get rid of those leading spaces, is what's happening here. So I'm splitting the string, and then what I get back, though, is not a string. I get back a slice of a string. That's sort of this weird abstract thing. And then I call map, and I say, for each value that I get out of this split, because split returns an array of strings, I'm going to map, or excuse me, an array of slices. I'm going to map that to a string init, which converts to a string. So a little bit weird, right? So I have the split thing. The split thing gives me back this array of kind of strings, but not really. And then the last thing I do is I use map to say, now convert that to a real string. So in the end, what I get out of it is not a string of sort of strings, not really, but I get an array of strings. That's a little weird. It's just something I had to work around because of the way Apple does this right now. And then I go through and I look for the first split, turn that into a double, check to see if it's higher than my than the current hog, which is, or the first value in the current hog, which is this guy, right? My first iteration through is just 0. So if it's greater than that, I'm going to say, yep, this is bigger than that. So I'm going to make a note, return the name of the current function or the current process I'm looking at, and the value. So does this make sense? So every iteration, it's going to say, I'm going to look at what I've got. I'm going to check how much processor time it's taking. If it's more than my current thing I think is taking the most processor time, I'm going to return my new value, my new process value, my new processor percent. Does anybody have any questions about that? Does that make sense? I'm seeing some blank looks. If it doesn't make sense, I can maybe clarify it. But right, so this is the reduce. And if we go down, let's get rid of this guy. I may have also just confused. Okay, go. Okay, so here we go. So the thing that's hogging most of my processor right now is Xcode, believe it or not, because it's running the process and doing all the work. And it's taking 23.1999% of my processor. So that's reduce. you can use it for all kinds of things, but it takes a little bit of imagination. The really interesting thing is, so reduce does care, right, about order. I'm always applying the function to a current set of data plus the thing that preceded it. But there's actually ways to write parallel reduces. And they're complicated and ugly, but you can do it because you do know enough about how it works that you can count on the semantics and write them. I'm not going to go into that at all because that's a lot of stuff. Anyway, so it's kind of fun. You can chain things. So suppose if we go back to my example where I was going through and digging for let's just do this one. No, we want the map one. So let's do this. Suppose we go back to where I was looking for all my bundle IDs. And I just want bundle IDs that have Apple in them. Let's take this guy back to map. Map A, make sure that things are okay, so that should work. Let's see. Yeah, it didn't crash. Didn't actually run the code either. What did I miss? Oh, that's because, no, it did run it, I just didn't print it out. So let's go ahead and print map A. So by just slapping a filter on the end of this that says, look for the word Apple in the thing that came back, I can get just a list of applications whose bundle ID includes the word Apple. So if you were looking for some vendor you're trying to get off your system, you could go through, look for a list of bundle IDs that that included their name, and you're off and running. But again, you can chain these. You can chain reduces into this, and things start to get really ugly. But you can do that. Now there are entire database systems that are built on this idea, right? MongoDB and some of the unstructured, the NoSQL databases are really built around this idea of map and reduce and filter, and that's how you do your queries. So it's being recognized as a pretty powerful concept. So that's hopefully an introduction on how all this stuff works. I had originally planned on talking about the PMAP next, but I already talked about it. So these are some references. This is where I originally got the code for the parallel version of map. It was actually originally written for Swift 2. I had to do some work on it to get it to work with Swift 3. The stuff about dealing with Objective-C exceptions, I cut most of that out because it's kind of weird. Like I said before, if I do something really naughty, like I try to add 2 strings when I don't have, instead of integers or something, I do something that the system just doesn't know how to deal with, it throws Objective-C exceptions, which are not Swift exceptions. To make that more complicated, Swift has a try-catch structure like you would expect an exception. It doesn't catch Objective-C exceptions. It does something completely different. So anyway, but then again, there's the link to the playground. And that's it. That's all I had to say, really. Does anyone have any questions or things they want to know about Swift or anything else? Yeah.
My main question is, how would you do this without building an actual applet that you would use?
Okay, so that's, you know what? That is a great question, and I have something to show there, too, that I forgot to show. Okay, so one of the kind of fun things about Swift is, well, it's kind of interesting. FC. So this is a Swift application, or a Swift program. It's a command line Swift program. You can see I've got a shebang at the top. So if I have the development tools installed, I can actually just run this like I would any shell script. So I can say /fc.swift. Whoops. And there's the program running. In the background, it got compiled and run. That's one way to do it. Obviously, also, you can just, inside of Xcode, you can say, I want to create let's grab Xcode. You could say, I want to do a new actual project and tell it that you want to do a Mac OS command line tool. Give it some information. What does it want? com.me. And give it a place to go. And now, yeah, my contacts. Oh, right, forget. Yeah. Now I've got a Swift. I can go ahead and I can just start hacking away in here too. And then now here I would compile it and it would spit me out just an application. Or, I can just from here, I could say, I'm trying to remember if it's, Swift C, fc.swift. That's going to compile my code, that little example thing. And now I've got something called just fc that I can run. So you got all kinds of options, right? But it is kind of fun, the whole, you can just put the shebang on the front, and if you've got the Swift tools installed, you can just pretend you're scripting. It does compile it, so the first time you run it, it takes a minute. But from then on, it goes pretty fast.
So the fact that it throws...
Oh, we're supposed to be doing this thing, aren't we? Man, I gotta keep up. Sorry.
So does the fact that it...
I don't think that's on.
Okay.
I don't think our mic's on, so I'll just repeat it.
So does the fact that it throws Objective-C exceptions indicate that it's like translating it to Objective-C as part of the compilation?
Okay, so the question is, the fact that it shows throws Objective-C exceptions, does that mean it's Objective-C underneath? To some extent, that's true, yeah. It still has an Objective-C engine underneath it. It's not translating to Objective-C, but a lot of the runtime, if you go back to the playground, you'll notice the first thing I do is include Foundation, which is the Objective-C framework for doing all of the system stuff. It has a really tight binding still to Objective-C. There's still a lot of stuff they share, so yeah. Any other questions? All right, well, thanks. Please fill out the feedback. I'm trying to figure out how well this kind of talk works for system administrators. How many of you are starting to get into Swift? I think Swift's got some cool features that might be useful, and it's super powerful, so thanks.